Good morning, students. Let us discuss about motion, in which we have already discussed in the previous lecture about acceleration. Acceleration, that is denoted by A, and acceleration is defined as the rate of change of velocity. Velocity means speed in a particular direction. And in the terms of physics, rate is denoted means to divide by time. So change in velocity means final velocity minus initial velocity divided by time, that is acceleration. फाइनल वेलोसिटी कौन सी होती है? जब कोई ऑब्जेक्ट मूव करना स्टार्ट करता है उस वेलोसिटी को, उस स्पीड को हम बोलते हैं इनिशियल वेलोसिटी, और जो बाद वाली स्पीड होती है उसको क्या कहते हैं? फाइनल वेलोसिटी. सो फाइनल वेलोसिटी माइनस इनिशियल वेलोसिटी डिवाइड बाय टाइम इज एक्सेलरेशन. Its unit is meter per second square. As it is velocity, so it has direction also, so it is a vector quantity. Body is moving in the same direction and speed is increasing, means velocity is increasing, then acceleration is positive. And if you can say final velocity is decreasing, means if final velocity is less than initial velocity, then the acceleration is negative, and negative acceleration is known as retardation. Let us discuss about graphs. First is distance time graphs. Graph is always taken between two variable quantities. When two variable quantities are given and we plot the graph, that is, if we take time on x-axis and distance on y-axis, then the graph will be shown by speed, or you can say motion. It will represent motion. Now here just see this graph. On x-axis it is time and on y-axis it is distance. An object is placed at A. After some time, its distance is not changed, time is changing. At point B, the distance remains same and the time is changed. So this shows that body is at rest. So when an object is rest, time changes but distance does not changes. Now come on the next graph. In this, on x-axis time and on y-axis distance. And this line shows the uniform speed, means if time is increasing, distance is also increasing. And straight line graph always indicate accelerated motion, means after some time the speed is increasing uniformly. So this graph indicate about uniform motion, or you can say accelerated motion. For accelerated motion, the slope of graph is increasing with time. And if the slope of graph is like this way, decreasing with time, that is deaccelerated motion. The next type of graph is velocity time graphs. When we plot the graph between velocity and time, we get the slope indicates the acceleration. Suppose on x-axis I am taking time, on y-axis we take the velocity. If the line is like this, which shows the constant velocity, means speed of the object, or you can say velocity of the object is not changing, then it will indicate zero acceleration. The acceleration will be 0. Why? Because acceleration is change in velocity. But in this graph, velocity is same throughout, so it is showing 0 acceleration. In the next graph, you can see the on x-axis time is taken and on y-axis velocity is taken. And the graph is like this, a straight line. This is showing uniform acceleration. The velocity is increasing with the increase in time uniformly. But as it is starting from 0, so initial velocity will be 0. Here initial velocity is 0 and this line, A line, shows the uniform acceleration, and in this graph it is shown 0 acceleration. This graph indicates that object is starting from rest and moving with uniform velocity, means increase in velocity is same, so the graph is like this way. Greater the slope and greater will be the acceleration. But just see this graph. In this graph, time is on this axis and velocity is on y-axis. An object has some velocity. Initial velocity is not 0. Suppose it has some velocity, an object start from moving A, so graph will be like this. It is uniform acceleration, but initial velocity is not 0. In this graph, time is taken on x-axis and initially object has some velocity. Suppose it started from A point and its velocity is decreasing and it reaches after some time at point B, means the velocity becomes 0. So this negative slope shows at the negative acceleration, or we call it as uniform retardation, because the velocity is decreasing uniformly, so it is uniform retardation. If velocity is decreasing, then the line shows retardation. If the velocity is increasing, the slope indicates acceleration. This velocity time graph, this graph is showing uniform acceleration. Time is on x-axis and velocity is on y-axis, and it has initial velocity 0 because it is starting from this point. And see this graph. This is first it is increasing, then it is decreasing, then it is increasing, then decreasing, then increasing. So this zigzag graph line shows the non-uniform acceleration. This straight line indicates uniform acceleration and this line indicates non-uniform acceleration. So we can discuss like this also. From this point to this point, it is acceleration. From this point to this point, retardation. Again from this point to this point, acceleration. And this point to this point, because it is decreasing, negative, so it is retardation. Now it is increasing, so it is acceleration. So this is all about the graph. Tomorrow we will discuss equations of motions.